Welcome back reinforcement learning. This session I explain applying bandits to optimize ad placements. Okay. Nowadays everything is digitalized. Now the marketing also in digitalized. So in this digitalized era, the advertisement placement is a very critical role, play the critical role to give the ads to improve the to increase the business profits and maximize the returns. The advertisement placement is the critical task. So this task is the performed with the reinforcement learning algorithms. In efficient way, we get the more returns on investment. So we solve the advertisement placement is performed with multi-R bandit problem. Multi-R bandit problem is suitable for the advertisement placement. We already introduced the multi-R bandit problem. The multi-R bandit problem is the gambler type of game. There is a number of slots are there, or number of arms are there. We open the arms, they give the returns, or they give the rewards, or not given the rewards. Okay, so the main objective of the multi-R bandit problem is to maximize the cumulative reward. Maximize the cumulative reward. So the same is applied, and same is applied into ad placement to improve the number of clicks on the digital advertisements, to improve the number of clicks on the ad placements. Okay, that is we solve with using multi-R bandit problem. In multi-R bandit problem is applicable. We are applying the multi-R bandit problem for the ad placement to improve the number of clicks on the ad. This ad placement is in real world, it is the context matters. Context matter play the key role in ad placements. So the context matters play the key role means we observe the customer behavior and customer previous history and customer using website. Okay, we all are study the context. What is the customer using website or browsing history? They are played the key role in ad placement. So this scenario is better modeled by contextual bandits, where the choice of action means which ad to display, which the action is which had to display. In multi-R bandit open the arm is the action. Here the action is which ad to display. This action is depend on state. What is the state? State is the contextual information about the user. The state of the environment is a contextual information about the user, like using site or browsing history. Okay, all are the contextual information of the user. So their action is which had to display on the state of the environment is the contextual information about the user is play the key role in contextual bandits. Here in reinforcement learning, the key elements, the state, action, rewards. Okay, what are the state, action, rewards related to the ad placements? The state represents the contextual information available, like such as the current website, the user using current website, and browsing history, and the product they just purchased. Okay, these all are play the key role in state of the environment of the user. The next one is action. Action is available ads. The actions are the set of possible ads that can be displayed to the user. Okay, for example, a user is the website related to the jewelry. We can place the either related products like watches, handbags, those type of ads we played in jewelry website. Okay, that is the suitable ads for the customer. Next one is reward. After reward, the reward is the feedback from the user. Okay, feedback from the user we received after applying the action is in ad placement. The rewards are either click on the ad or not. Click on the ad or not. Here click on the ad means reward is 1. Not click on the ad, reward is 0. So the state is the browsing history of the user or user using website or purchasing information that represent the state. Action is add, available ads, possible ads to place on user site. And reward is click on the ad or not, that is the reward. The main objective is to maximize the cumulative reward by learning which actions are most effective in different states. Okay, this is the main objective in ad placements. So here implementing the contextual bandits with deep learning. Why here the contextual bandits we are implemented with the deep learning. Why? In state space, the small state space, we can use the lookup tables are enough for the small space of the small state space information to store the small space information. Lookup tables are enough, but when we are using large state space, we require the more space. In that case, the lookup tables are not suitable. Now then we are using the deep learning neural networks. They are used to approximate the function between the action and state and actions. Okay, the neural networks can be employed to approximate the function that maps states to the optimal actions. So this state and action pair we can't store using lookup tables. So we are trained with the neural network to get the optimal function, approximate function to map the both states and corresponding actions. So for that in the ad placement, the neural networks could be trained to predict the likelihood of user clicking on specific ad or not, okay, based on the state. So we have give the training, pre-trained for the neural networks to predict the user reaction on the ads. So the neural networks we are using for the huge amount of state space data storing. During the training they create the approximate function between the state and actions. Next one is we are using shortcut action selection for clicking get the best reward. In multi-arm bundle problem is solved by using shortcut selection policy, which has the highest probability. Okay, we choose that one. The same we are apply the shortcut selection process in ad placement, which has the highest predicted user. In that user site we place the ads. Okay, in the shortcut action policy, the temperature parameter plays the key role. This is a very sensitive, the temperature parameter. The temperature parameter is we maintain the high value for the exploration, low value for the exploitation. So it is a very important in softmax action selection. The next one, practical applications. Okay, when in the e-commerce company website, we have the multiple the different product categories are available. Okay, any user using one site, okay, we are place the another site where ads that another site is related to the present using site. For example, the jewelry the user is on jewelry website, we can place bags or watches type of ads. They are suitable for that website. So this type of analysis is performed in practical applications. We are using deep learning techniques. So we are using deep learning techniques to approximate to create the approximate function between the states and actions. The states means the user behavior, the user attitude, user taste, and all of the state. The actions are the available ads are placed or not in for the particular user website or user site. to our main objective is to increase the ad placement strategy to maximize click through rates. Ad placement strategy to maximize click through rates. So here the conclusion of this ad placement, the agent here is neural network. The agent is neural network is fed into state information. The state information is current website. Okay, agent of the neural network agent is fed into current website state information, choose action from available ads. Choose action from available ads. This available ads is a action space. Okay, from available ads, the agent places the advertisement. Agent places the advertisement. After placing advertisement, user clicks generate the rewards. If user clicks on the ad, it gives the positive reward. If not click on the ad, it gives the negative reward or 0. So in multi-arm bandit problem, applying the bandits to optimize the ad placements, we are using balancing techniques, exploiting balancing techniques, automatic selection policy with neural networks, with neural deep learning techniques for to create the function, to create the pair matching of the actions and the states. Okay, the deep learning techniques with the trained, they map the states and the corresponding actions. Okay, we are implement the bandits to optimize the ad placement by using deep learning with multi-arm bandit reinforcement learning algorithms. Thank you.